All right, here we go. This is Unit 9, test review, page 4, part 2. All right, let's see what we got here. Similarity. Similarity with three-dimensional shapes we really have to be careful with. And I kind of, in the last video, went over it down here with like comparing square feet with square inches and cubic feet to cubic inches, right? So when we add a new dimension onto things, we really have to be careful about how we do this. So we really have to pay attention to our units on problems like these. I know I haven't been too picky on, units in the past, but this is going to be one section where it does, it is important. So if we look at this one, we have two similar, right? That's the key word. They're similar. That means they're the same shape. They're just different sizes. Okay, so they share a scale factor between them. Now, if we look at this one, they have similar heights. Now, heights are a linear unit, right? I'm going to measure how tall something is in feet, in inches, in miles, in yards, what have you. But it's just yards. It's just inches. So, um, the height, the linear unit, is kind of our starting point. Now, if I'm looking at areas, how do we measure areas? That's feet squared, inches squared. It's a square unit, right? So when I compare this, I don't want to say 9 over 12, right? Because that would be like 9 feet over 12 feet. What I want to do is I want to square both of these. I need to turn it into a squared unit. All right, so that needs to be 9 squared over 12 squared. All right, so what does that give us? That's just going to be 81 over 144. All right, that is the ratio of the lateral areas. Now, in the next one, it's a volume. So volumes are measured in cubic units, inches cubed, feet cubed, what have you. So now what I need to do is again, take that scale factor, that linear ratio here, so that 9/12, and what I need to do now is I need to cube it. Right? So 9 cubed, I don't have a clue what that is. Um, it's 729 divided by 12 cubed, which is 1728. Let's get that out of here. 1728. All right. Now, you should always try to reduce these fractions. 81 divided by 144, that can be reduced down to 9/16. All right, so I should have done this in the beginning. And then this one, that can be reduced down to 728. What is that? 729 divided by, that can be reduced down to 27 over 64. Right, so that I really should have done that in the beginning. If I look at this 9/12, right, 9/12, that's going to be the same thing as 3/4. Right. So, and if you look at it, it still all works out, right? Because 3 squared is 9, 4 squared is 16, and that is 9/16. The third one, 3 cubed is 27, 4 cubed is 64. That gives us that same ratio. All right, so when you simplify things first, it does make life a little bit easier, so just kind of keep that in mind. All right, now on the next one, this one is different because we have similar lateral areas. How do we measure lateral areas? That is a squared unit. All right, so I want to work backwards to the similarity ratio. So what I need to do is I need to take the 25 over 36 and I need to square root both of these. All right, what is the square root of 25? That's just 5. What is the square root of 6? 36, sorry, 6. All right. There's your similarity ratio. That is your linear unit that we're kind of talking about. Now, to find the volumes, what do you do with the 5/6? Well, you need to just cube it. Right? And that's going to give us 125 over, I think that's 216. Right? And that one's done. All right. One more on this page, then we'll call it a day here. And then I got to go break my computer because it's not cooperating with me. I don't like this computer. I want my old one back. All right, two similar cones have volumes. All right, volumes of 54 pi and 250 pi. If the lateral area of the smaller one is 63 pi, they want us to find the lateral area of the larger cone. So we'd think these are volumes. So volume is a cubic unit. All right. So if I kind of look at this cubic unit, I'm going to compare these. Remember, ratios you can write as fractions. That's what I'm going to do. 54 pi divided by 250 pi. All right. So just first thing first, simplify those fractions. So 54 divided by 250. The pi's do end up canceling. This doesn't simplify, to anything particularly nice, but these numbers are going to be useful because this is a cubic unit. So we're trying to work our way back to the linear unit. Right? So since they're cubic units, we have to cube root both of those, right? And if you look at the cube root of 27 and the cube root of 125, those are nice numbers, right? So the 27 over 125, upon first glance, it doesn't look that friendly, but it turns out they are because cube root of 27 is 3. The cube root of 125 is 5, right? Now, the last thing we need to do is since we're looking for a lateral areas are squared units. So I'm going to take this guy and I'm going to turn this into a squared unit. All right, so what I'm going to do, I'm going to take 3/5 and I'm going to square both the top and the bottom. And that gives me 9/25. All right. And this is not our final answer, but this is our ratio of the lateral areas. All right. And that is the number I need to compare with that 63 pi. So if we just kind of make a chart out of this, we have a small shape and we have our big shape. We have our area ratio and we have our actual area. All right, so if we just make this into a chart, right, we know the area ratio was 9/25. Right? And the actual area of this guy, of the smaller one, is 63 pi. Right? This is the guy we're looking for. And if you want to think back to Unit 6, when we were making proportions, all we have to do is take these two fractions and set them equal to each other, right? And this is going to give us our final answer. So what we can do is we can say, all right, 9/25, that equals 63 pi. And instead of a question mark, I'm going to throw an X in there. And then that is going to be our answer. Let's go ahead and cross multiply that. I got 9x equals, I don't have a clue what that is, 63 is 25. That's 1,575 pi. All right. Now, I don't know if that divides nicely. Let's see. Oh, it is. So that gives us 175 pi. All right. So again, units are a big deal here. So let's just make sure we are talking about our units, and they actually don't give us any. So this is units. All right, but it's an area, so it's squared units. All right. So there you go. That was how we compare the scale factors, areas, volumes, heights, that sort of thing. Really think about what unit you're using. Are you using inches? Are you using inches squared, inches cubed, right? And make sure you are converting from one to the other. All right. But there you go. That was the second part of page 4, and then we got one more page. See you in the next one.